In this video, we're going to be simplifying square roots and then looking at square root equations. In an earlier lesson, we learned how to solve equations that involve taking the square root as the final step in order to solve for the variable. In each of those equations, the result was a solution that was a whole value. In this lesson, though, we're going to look at equations where the solution isn't going to be a whole value when you take the square root. And we're going to see how we can write the exact answer of these types of numbers. Before that, though, let's just take a look at products of square roots. In example A, we have the square root of 4 multiplying the square root of 9. Before I do the multiplication, I better figure out which numbers I'm working with. All right, 4, the square root of 4 is equal to 2, and the square root of 9 is equal to 3. So here I'm going to do 2 times 3, which is going to equal 6. Okay, so just one thing to remember, though, that when you take a square root, there's actually two answers, a positive and a negative, that have the same absolute value. So the answer here, we're actually going to have two answers. It's going to be positive or negative 6. All right, and if you look at letter B, it looks very similar to letter A, except now it's the square root of the product 4 times 9. Here it was the product of the square roots, but here it's the square root of the product. Before I can do the square root, I need to know what number I'm taking the square root of. So I'm going to do 4 times 9, which is 36, and then I'm going to do the square root of 36, which again is positive or negative 6. In example C, we have the square root of 4 multiplying the square root of 25. The square root of 4 is 2, and the square root of 25 is 5. 2 times 5 is equal to 10. And again, there's going to be two answers, positive or negative 10. Finally, in letter D, now we have the square root of 4 times 25. So again, it looks similar to this, only we have to multiply first. 4 times 25 is 100. And then if you do the square root of 100, you're going to get positive or negative 10. And so hopefully you notice a very important property for multiplying square roots. If you take the product of the two square roots, you should get the same answer as if you do the square root of the product of the numbers. In each case here, we got positive or negative 6. In each case here, we got positive or negative 10. This is the multiplication property of square roots. All right, so if I have the square root of A and I'm multiplying it by the square root of B, well, that's the same as the square root of A times B. The product of the square roots is the same as the square root of the products. It also works the other way. If I have the square root of A times B, I can rewrite it as the square root of A multiplied by the square root of B. And this property is going to be very useful a little bit later on in the lesson. Now, one use for this property at the beginning here is to find the product of two unfriendly square roots in order to get a nice result. In example A, I have the square root of 2 multiplying the square root of 8. Well, 2 and 8, neither one of those numbers is a perfect square. So what I'm going to have to do is use my property up above to see how I could get a nice answer out of this. All right, the square root of 2 is going to be some irrational number that goes on forever without repeating. Same thing with square root of 8. But I can rewrite this now as the square root of 2 times 8. All right, as we saw up above, the square root of A times the square root of B is the same as the square root of A times B. So the square root of 2 times the square root of 8 is equal to the square root of 2 times 8. And if I multiply 2 and 8, well, then that gives me the square root of 16, which I can definitely evaluate. The square root of 16 is either positive or negative 4. And so that's the answer to this product. All right, so we just looked at this example here where the square root of 2 times the square root of 8 was the same as the square root of 2 times 8, which is the square root of 16, which is positive or negative 4. And I just want to bring out my calculator here to show you what you can do with square roots on a calculator. So if you have this calculator, which this is the TI-30X2S, this is the calculator that I prefer that you use. All right, to do a square root, what you're going to do, you're going to first hit that second key right there, and then you're going to hit this x squared button, and it's going to bring up the square root symbol with an open parenthesis. Then you just type in the number that you want to find the square root of and hit enter. All right, so the square root of 2 is this decimal, again, that doesn't terminate or repeat. This is an irrational number. All right, so if I didn't use this property over here, I would have to write out this entire decimal for the square root of 2. And then I would have to multiply it by the square root of 8, which if I type this into my calculator now, the square root of 8, I get this long entire decimal. And then I have to multiply those two decimals together, and it just becomes a pain to do. All right, so that's how you can do a square root on the calculator. Now, I can also just punch in this entire expression and show that the answer is 4 or negative 4. The square root of 2 multiplied by the square root of 8. And my calculator gives me the answer of 4, but we just also need to remember that negative 4 is also a possibility. So 4 and negative 4 would be the answers to this problem. So that's how you do a square root on the calculator. Hit the second key, hit the x squared button, and then type in the number of the that's underneath the square root symbol, and then that gives you your answer. Let's go ahead and apply our multiplication property of square roots on two different examples. Here we have the square root of 12 multiplied by the square root of 3. 12 and 3, neither one of those numbers are perfect squares. So if I were to take their square roots, I would get some non-terminating, non-repeating, irrational number. So what I'm going to do instead is use my property up above. I can do the square root of a times the square root of b is the same as the square root of a times b. The square root of 12 times the square root of 3 is the same as the square root of 12 times 3. And this becomes the square root of 36. 12 times 3 is 36. And I know the square root of 36, that's going to be positive or negative 6. In example C, the square root of 20 times the square root of 5, I can rewrite that as the square root of 20 times 5. And then when I multiply 20 and 5, I get 100. So now I have to do the square root of 100, which is just going to be positive or negative 10. So again, you can take the product of two different square roots and make it the same as the square root of the product, and that will help you to come up with your answer. So now that we're familiar with the multiplication property for square roots, well, what happens when the number underneath of your square root symbol isn't a perfect square? Well, we talked about this a little bit earlier in the video, but we also talked about it in topic 1. The square root of a non-perfect square will always be an irrational number. Okay? Any square root of a non-perfect square is an irrational number. This means that your answer will be a decimal that never terminates, meaning that it never stops, and that decimal also never repeats. A decimal that never terminates or repeats. Rather than writing that answer in decimal form, it is possible to write the answer as a simplified square root. And that's what we're going to do here in the next example. We're going to learn how we can simplify a square root. The first thing that we're going to do is list out the first 10 perfect squares starting with 1. Okay, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and then we would have 16, 25, 36, 49, 64, 81, and 100. Those are the first 10 perfect squares. I'm now going to see how I can simplify the square root of 18. 18 is not a perfect square. It doesn't appear in this list here. There's no whole value times itself that equals 18. So what we want to do is try to simplify this square root, and we're going to do that by using our perfect squares. We're going to look at this list of numbers and figure out, is any of these perfect squares a factor of 18? Does any of these numbers go into 18 evenly? And looking at my list, well, I know that the number 9 is a factor of 18. 18 is the same as 9 times 2. Okay, so using that fact then, if I'm doing the square root of 18, well, then I can rewrite it as the square root of 9 times 2, because 18 is the same as 9 times 2. And now I can use my multiplication property to break this up. The square root of the product is the same as the product of the square roots. I can rewrite this as the square root of 9 times the square root of 2. And now when I look at these two square roots, I know that I can figure out the square root of 9. The square root of 9 is either going to be positive or negative 3. All right, and then we're going to take that and multiply it by the square root of 2. And this is your simplified square root. The square root of 18 is equal to positive or negative 3 radical 2 is how we say that. Positive or negative 3 radical 2, or 3 times the square root of 2. This is known as simplest radical form. And when I say the word radical, I just mean square root. Okay, so this is positive or negative 3 times the square root of 2, or positive or negative 3 radical 2. So again, you're going to look at your list of perfect squares and you're going to see, is any of these a factor of the number underneath of the square root symbol? The key here is to find the largest perfect square that is a factor of the number underneath of the square root symbol. Let's try that underneath with some more examples. Here I have the square root of 8. 8 is not one of my perfect squares. It's nowhere in my list up here. So I'm going to look at this list and see if any of these numbers is a factor of 8. Which of these evenly goes into 8? Well, I know that 4 evenly goes into 8. All right, 8 is the same as 4 times 2. So if I had the square root of 8, I could rewrite that as the square root of 4 times 2. And then if I use my multiplication property, I can rewrite this square root as the square root of 4 times the square root of 2, and then you can evaluate the square root of 4. The square root of 4 is positive or negative 2, and then we would multiply it by the square root of 2. So the square root of 8 is the same in simplest radical form as positive or negative 2 radical 2, plus or minus 2 times the square root of 2. How about the square root of 45? Well, again, which of these perfect squares evenly goes into 45, which is a factor? Well, 9 is a factor of 45 because 45 is equal to 9 times 5. So if I were to do the square root of 45, I could rewrite that as the square root of 9 times 5. And then I can use my multiplication property to write this as the square root of 9 times the square root of 5. And then if you were to evaluate the square root of 9, that's going to be positive or negative 3 times the square root of 5. So in simplest radical form, the square root of 45 is positive or negative 3 radical 5. In letter C, we have square root of 48. How can we simplify it? Well, looking at our list, we want to find the biggest perfect square that's a factor of 48. I know that 4 is a factor of 48. 4 times 12 is 48. But 16 is as well. 16 times 3 is 48. And no other number here will be a factor of 48. So let's use 16. All right. So 48 is the same as 16 times 3. So the square root of 48 is equal to the square root of 16 times 3. And then I can break up this square root into the square root of 16 times the square root of 3. And then I can evaluate this square root here. The square root of 16 is positive or negative 4, and then multiply it by the square root of 3. So in simplest radical form, the square root of 48 is positive or negative 4 radical 3. All right, so that's how you're going to be simplifying your square roots. Can you find a perfect square that's a factor of the number underneath of the square root symbol? And then you can use your multiplication property to help you simplify and write in simplest radical form. Now that we understand how to simplify square roots, we can solve equations where the answer will not always be a whole value. In our next problem, they want us to solve the equation below graphically and, if necessary, to write our answer in simplest radical form. All right, so I'm going to try to figure out what the value of x is in this equation. Negative 7 plus 3x squared equals 77. Just like any equation, I've got to try to isolate this variable. So I'm going to start by trying to isolate the entire variable term first, which means I'm going to add 7 to each side. And when I add 7 to each side, I get 3x is equal to 84. All right, and now what I'm going to have to do is get the value of 1x squared instead of 3x squared. So I'm going to divide each side by 3. All right, and that's going to leave me with x squared equal to 84 divided by 3, which is 28. And now to get the value of x, I'm going to have to take the square root on each side. The square root of x squared is x, and it's equal to whatever the square root of 28 is. Now, the square root of 28 is going to give me an irrational number because 28 is not a perfect square. If I were to have my calculator here and punch in the square root of 28, you'll see that I'm going to get a decimal that doesn't terminate or repeat. Now, this is just a calculator approximation because, again, this decimal goes on forever. I want to know what's the exact value of the square root of 28, which means I'm going to write it in simplest radical form. So I'm not going to write out this decimal here. I'm going to take the square root of 28 and see how I can simplify it. What perfect square is a factor of 28? Well, 28 is the same as 4 times 7. And so if I do the square root of 28, that's the same as doing the square root of 4 times 7. And the square root of 4 times 7 I can break up into the square root of 4 times the square root of 7. And then when I evaluate the square root of 4, that's positive or negative 2 times the square root of 7. So our answer here, x is equal to positive or negative 2 radical 7. There's our answer, and it's written in simplest radical form. In our next example, we're going to solve these equations algebraically. If necessary, write our answers in simplest radical form. Here we have 4n squared plus 3 equals 75. I'm going to start by subtracting 3 on each side so that I can isolate the variable term 4n squared, and it's going to equal 72. Then I'm going to divide each side by 4, which means that n squared is going to equal 18. And now to get the value of n, I'm going to take the square root of each side. So the square root of n squared is n, and I'm going to get the square root of 18. 18 is not a perfect square, so I'm going to see how I can write my answer in simplest radical form. So n is going to equal something. Let's figure out what that is. All right, well, 18 is equal to the product of 9 times 2. 9 is the biggest perfect square that goes into 18. So if I do the square root of 18, that's the square root of 9 times 2. And now that's just the square root of 9 times the square root of 2. And the square root of 9 is positive or negative 3 times the square root of 2. And so our answer here, positive or negative 3 radical 2 for our answer. In example B, we have negative 15 is equal to negative 2c squared minus 7. Again, we've got to isolate our variable term first, so I'm going to start by adding 7 to each side. That gives us negative 8 on the left, and it's equal to negative 2c squared on the right. Now I'm going to divide each side by the negative 2, and that's going to give me 4 equal to c squared. And now to figure out the value of c, I have to do the square root on each side. The square root of c squared is c, and the square root of 4, well, 4 is a perfect square, so this is nice. I'm not going to have to write my answer in simplest radical form like I did over here. The square root of 4 is positive or negative 2. C equals plus or minus 2. So I wanted to show you an example from Delta Math. So this is actually a question that I got when I went into Delta Math, and it says 139 equals 8y squared minus 5. We're going to solve this equation, and I'm going to show you how you can put your answer in Delta Math. So let's first isolate the variable term 8y squared by adding 5 to each side. And when you do that, you're going to get 144 is equal to 8y squared. All right, and now we need to get the value of y squared, so let's go ahead and divide each side by 8. And when we do that, 144 divided by 8 is 18, and it equals y squared. So now what I need to do to get the value of y is take the square root on each side. Okay, well, the square root of y squared is y, and the square root of 18, well, 18 is not a perfect square, so now I'm going to write my answer in simplest radical form. And we did this a little bit earlier in the video, actually. The square root of 18 is the same as the square root of 9 times 2, which is the square root of 9 times the square root of 2, which is positive or negative 3 radical 2. So here our value of y is positive or negative 3 radical 2. There's two different answers. There's positive 3 radical 2, or there's negative 3 radical 2. These are the two answers to the problem, and I'm going to show you what you can do in Delta Math to type in your answer. All right, so we had just solved this equation, 139 equals 8y squared minus 5, and we had two answers. We had positive or negative 3 radical 2. So there's two answers to this equation, and right now in my answer spot, I only see a place for one. So what I'm going to do, I'm going to click this plus sign right here, and now it breaks it up so that I have two different answers. And now I'm just going to type in what my two answers were. So one of them was positive 3 times the square root of 2. So I just type in 3 and then hit that square root button and put 2 underneath of that. The other one was negative 3 times the square root of 2. And it doesn't matter if you put the positive one first or the negative one first. You just have to enter in both of the answers. And then we can go ahead and submit. And there we have it. Okay, we have successfully entered in our answers to this problem.